This is Radio TV Phono Nut, and what we have today is a Philco model 39-70 4-tube battery-operated AM radio from 1939, as the model number indicates. Cabinet's in pretty good shape. As you can see, scratched up a little bit, but could be a whole lot worse. Now, I could have swore when I got this set that the dial pointer was there, but as you can see, it's not there now, and I've looked all inside the cabinet and can't find it, so I don't know what happened to it, so I'm going to have to find a dial pointer and a screw to attach it. But other than that, it's all there. Here's the speaker. It's in nice shape and not dragging. This is your typical battery-operated farm set that runs off of 1.5 volts and 90 volts. And these old cables are kind of worn out and need to be replaced. Here's something I built years ago from a kit from Antique Electronics Supply, and it's been used and abused and knocked around over the years and needs a little repair, but I think I've got it working good enough to power this radio. As you probably figured out, this is a power supply that's designed to operate the old battery-operated tube radios, even the ones from the 1920s. We have a adjustable filament supply that I think goes from like 0 to 9 volts or something, I don't remember. And then we have a variable C supply, which is our bias voltage, which doesn't seem to be working right now. And then we have a tapped B supply that goes from 22 up to 135 volts DC, which is handy for working on all sorts of battery-operated radios. One day what I intend to do is build this into a box and put meters on the box and actual potentiometers instead of these trim pots, which this A trim pot is already worn out from use. I have it set to a spot that'll give me about 1.7 volts, and that'll work for powering the filaments in this radio. But what I want to do is one day mount all this in an enclosure and have metered outputs for the A and C supplies with pots on the front of the enclosure that I can actually adjust with a knob to the required output for whatever I'm working on. But so now let's trace out our battery cable and find out what connection's which and power this chassis up and see what it does. Well, in tracing out our battery cable wiring, I found something that's not good. I don't like finding things not good this early in the game. We have no continuity whatsoever across the two filament leads from our battery cable. The switch is good, and our ground connection's good. And all of the tube filaments are wired in parallel, so that only tells us one thing. That means that every tube filament in this radio is open. And I've seen that a number of times on battery sets, and usually what happens is the wires get frayed and the plug comes off from people grabbing the battery cable and yanking it by the cable, and it ends up breaking the wires off of the battery plug, and somebody that doesn't know what they're doing tries to reattach them, and they end up wiring the filament wires to the plate high voltage side of the battery and end up blowing all the tube filaments. Alright, we need a 1A7 for the oscillator and mixer. We need a 1N5 for the IF amplifier, a 1H5 for the detector and first audio, and a 1C5 for the output tube. So let me go scrounge around and see what I can come up with. Fortunately, these 1-volt battery tubes are not that expensive if you have to purchase them, but what's really sad about this case is all 4 of the tubes appear to be the original Philco tubes that came in the radio. And to me, that just makes it a little bit better when you still have the factory tubes, but when all 4 of the factory tubes are burned out, then we're going to have to change them with some that are not. So let me go dig through the tube caddies and the junk radios and the boxes and the this and the that and see what we can find. Okay, I think we might have found some tubes that will work. The output tube was a 1C5. From my research, it looks like a 1Q5 is a direct replacement, and a 1A5 has the same pinout diagram and heater voltage, but the bias is a little bit different according to the settings on the tube tester, but I think it should still work. The 1N5 I didn't have, but I found this in my tube stash. 1T4 adapter to 1N5, so that allows a 1T4 to be used in place of a 1N5. Now I need to solder on a grid cap on here, which I can obtain from one of these dead tubes. And one other thing, the tubes in this set are the tall variety, and a lot of the replacements, the newer replacements, are the short variety. And sometimes that poses a problem because the grid cap wire, such as what's coming out of this IF can, won't go down low enough to connect to the short tubes. You end up having to extend to add a longer lead for your grid cap. Alright, speakers connected, antennas connected, and let's flip it on and see what happens. Come on, click. Alright, I hear a racket from the speaker. Let's tune and see if we get anything.
Cut out profile impact protection. Take that minute. Go to sss.gov and register with. I mean, this you could be coming. If you told me today, hey, all.
And it works. Not as loud as it should be, but we don't expect perfect performance on the first try. The tuning condenser needs to be cleaned.
Randy Gregory, they've done all these things for all of these players. That's what they do. They have to go and say, who's a great player we can
Speaker sounds like it's got a bit of a rattle.
Strike gold on. This is just to get the rest of what Jason Smith and Mike Harmon say. Podcast it by searching The Jason Smith Show with Mike Harmon. And as always, you can hear The Jason Smith Show with Mike Harmon weeknights.
Alright, I'm about to start checking voltages, and before we do, let's get a kind of an idea about what our power supply is putting out. 86.8 volts on the 90 volt rail, which is normal. Now let's turn the radio on and see what we get. Come on, click. This thing's got a darn mechanical thing that flips to show you that the radio's on. It makes it kind of hard to turn this. Alright, so that dropped it down to about 72 volts. Yeah. Alright, let's check the plate voltage on the audio output tube and screen voltage. Plate is 69 and screen is 73. And of course the schematic calls for 77 on the plate and 82 on the screen, which it's going to be a little low since our power supply is putting out a little bit low under load, and that could be because of things in the radio drawing too much current, like leaky capacitors. Alright, let's look at 5, the control grid. And I'm getting 0.3 volts on that. That's a little positive, so let's take that capacitor loose and see what's really coming out of it. Yeah, it's very leaky. We've got 27 volts coming out of it. And 52 going into it. And our audio tube plate bypass capacitor has 4.3 volts on the other side, so not nearly as leaky as the coupling capacitor, but it's still got some leakage there, and it needs to be replaced. Alright, I replaced the coupling cap. That got us a negative voltage back on the control grid. That makes everything happy. And I replaced the plate bypass capacitor. I think we got a little more volume now.
We're here for you. Call us at 601-696-6756.
And turn the volume down. I'm not too crazy about these kind of tube sockets because they're not the type that have the through-hole terminals. You have to wrap the component lead around the actual socket terminal and crimp it and solder it. I like the ones with through-hole terminals better, but, you know, we deal with what we get, you know. What do? You either fix it or you don't fix it, and I'd rather fix it, so let's proceed. Another bypass cap in the front end. We got 34 volts on the input side of it. And 25 on the other side, so that one's very leaky too. And you can hear what the effect is when you have a open bypass cap or one that's severely leaky and not doing its job. You get motor boating and oscillation and squealing and undesirable noises that you don't want to hear, besides the undesirable noises that are broadcast over most AM radio stations these days. Now we got that cap changed. Now this cap here is the AVC filter capacitor. If it fails, it can also cause squealing and undesirable noises. So what we're going to do, we're going to take it out of circuit and see what it does, and then we're going to compare the results between the old cap and a new cap. You know, I try to do little things different on some of these videos so it won't be just the same boring thing radio after radio. And the purpose of this cap is to shunt off any stray RF or any junk that might happen to be on the AVC line to ground. So let's see what the radio does when that cap is not in circuit. Don't appear to be getting any reception at all. Alright, cap in place, cap out of the circuit. Now let's try a new cap and compare the results between the two. Now keep in mind this AVC filter doesn't have very much voltage across it at all, and a lot of these old capacitors will often perform okay when there's low voltage on them, but in a high voltage situation they'll leak like crazy.
Do that stuff. Do not
old cap,
401k because you're afraid.
New cap.
This time next year you'll be kicking yourself.
And I can't tell a bit of change.
No wonder, but
okay.
Yeah, get this mess covered. Don't pay on credit cards.
No apparent difference noted. Now, on a distance reception, weaker stations, you might notice something. But as far as on our local station, I can't tell a bit of difference in the world between the old cap and the new one. Try to get a clearer picture of that. I know y'all don't like my blurry camera. Now we have one more paper capacitor to deal with. It connects between the center terminal of the volume control, which is the audio output signal, and the other end connects to the control grid of the detector and first audio tube. Its purpose is to block any stray DC voltage that might be coming out of this volume control, which will not be very much, if any, and prevent any of that DC from getting to the control grid of the first audio tube, because if any DC gets to that control grid, it could upset the bias on that tube and cause it not to function properly. So before we clip it out, let's check the DC on the other side of it and see what's there. And then we'll do an A-B comparison between the old cap and a new one. So we got a little negative voltage there on the control grid of the first audio tube. That's what we want to see. Now let's clip the cap loose and just see if there's any DC on the other side of it. Cap is clipped loose. We have a pretty stout amplifier there. We got a little bit of positive voltage there, not that much. So let's do a comparison. Alright, voltage measurement between old and new. Negative 0.036. New one, nothing. New cap.
Because you can afford.
Can't really tell any difference between the two. Okay, we have one more capacitor, a 3 microfarad electrolytic capacitor between the B plus line and ground. Now, with this power supply being as well filtered as it is, it may not have any effect at all on the circuit, but if that cap opens, it can cause squealing and all kinds of junk. I've seen it happen too many times. We're going to jump it out, see if it makes any difference. Alright, we're taking out of the circuit, and in this case we don't have any filter hum, but we have modulation / ground loop hum. You notice when I pull the power, it cleared up for a second. Reading 4 microfarads, so that's good. Yeah, the ESR is a bit on the borderline, but you know, it's still usable. We'll go ahead and replace it anyway. Alright, I'm supposed to be reading 40 volts on the grid of the converter tube. I'm reading 34. That's no big deal, since the B plus is a little low anyway going to the set. However, this feed resistor is supposed to be 70K. It's reading over 90K. So just as an experiment, let's clip in a new resistor versus an old resistor and notice any performance changes and any voltage changes. Okay, the proper value resistor brought it up a whopping 3 volts and no apparent improvement in performance. So that just shows that a resistor can be way out of tolerance in the average tube radio, and oftentimes the radio will still work just fine. Alright, we're about ready to align this thing, and this particular Philco, like so many other Philcos from that period, uses an IF frequency of 470, so we'll set our generator to that. And that'd be about right there. Let everything warm up, and then we'll align the IF transformers. And yes, this thing is out of alignment because whenever I go off of 470 on the signal generator, it gets louder. Alright, let's get the screwdriver and tweak these things. Alright, let's cut the gain by the output back on the generator. Oh yes. Continue to cut the gain back, and we have one more trimmer. The second IF single trimmer for that is back here on the back of the chassis. Alright, that's pretty good. Now we'll cut the output of the generator down and repeat the procedure until no further improvement can be made. And now we set the generator and dial to 1530, which I have no idea about the dial because the pointer's missing, and adjust the tremors on the tuning condenser for maximum, and for that you need a 1/4 inch Philco alignment tool, which I don't have, so we're going to do a no-no and use a regular nut driver. And that was about maxed out. That's the oscillator. Alright, let's kill the signal generator and hook an antenna up and see what we get. It's not even quite dark yet. Here, let me clean this tuning condenser. I thought I'd give you your daily dose of... Never mind, you get the idea. Here's that classic country station out of Biloxi or Gulfport, somewhere right in that area, so if it'll pick that up, it's doing pretty good.
Keeping your identity and money.
Okay, I went ahead and fashioned up a new battery cable with my wire stash and some connectors. I stuck with the original color scheme based on the schematic, except for the green, which is A-. I didn't have any green, so I used black. So red is A+, black is A-, white is B+, yellow is B-. And I will put a label on the back of the radio stating which color is which, so we'll know what color to hook to what. Heaven knows we don't want to hook this up backwards and blow out another set of tubes. And we also replaced our crumbling grid cap wire, and I believe that's all the wiring we'll have to address. The other things that need to be addressed is, number one, the dial's probably going to need to be restrung because it gets almost up to the top and then it wants to stop. And that's usually a result of an old dial cord that's stretched over the decades. And let's see what else. Oh yes, this chassis reeks of cigarettes paste. So that's going to have to be cleaned, and the speaker is going to have to be addressed. It doesn't look broken anywhere, but I can hear it rattling. I think the cone may be coming loose from the actual voice coil itself. Maybe we can glue that back and retain our original speaker. And then that ought to about do it. Well, I want to try to find some more proper tubes for this, get the correct octal tube to put in place of this miniature job. It's on an adapter here. And that should about take care of it. Well, I turned it on and I said, why isn't it playing? And then I remembered I removed the output tube and stuck one of these duds in so I could use its top cap to perform surgery on the existing grid cap here. I didn't want to risk detaching the grid cap from the other tube, so it might work better if I put the correct tube in there. Now let's see what happens. It's better. K-A-A-Y, Little Rock. Oh yeah, and I need to find a pointer for this too.
News Radio 1200 WOAI.
Available everywhere with...
I think when I fix this, I'm just finish it, I'm going to rig it up on a battery pack, and then that way there won't be no modulation hum or no ground loops or any other noises that you get from power supplies.
Whether it's a team effort on a science project.
Yeah, there's our classic country station. Okay, so we got a little more to do to this, but not today. Well, here's the original speaker that I couldn't get fixed. I tried to solve its rattling problem, but didn't have any luck, and I've never really been that good at speaker repair, so this one's going to go in the pile for Speaker Freak 95. I've got a bunch of old speakers I've been saving for him that I need to box up and send to him one of these days after all this Crosley virus stuff kind of subsides. So I went through my speaker stack and found this cheesy Sound Design branded speaker that came out of a console stereo that we EOL'd. And I'm going to just tell you, even in a cheap tube radio, this speaker sounds like garbage. I kid you not, it's trash. So I dig through my junk stash and I found this CTS speaker that I think might have came out of a Magnavox, I don't know, but it's from the tube era, and the difference in sound quality is like day and night. In fact, this speaker I think is a better speaker than the one that came in it. So I put the radio all back together and turn it on, and I get hardly no audio. In fact, when I touch the control grid of the audio amplifier tube, I get this, very little audio. So yeah, that happens a lot. It seems like you can have them working great, put them back together, and they won't do squat. So let's get it apart and see what took a dump on us. Okay, under no load, we have 108 volts B plus going in, turned on. We're down to 73 volts. Something's choking the B plus down. And we got to find out what it is. I've already pulled the output tube and it came up a little bit, but not as much as I'd expect. So I'm going to pull the other tubes and see which one gives me the biggest increase. That'll tell me what stage is causing the problem. Well, I'm able to blow a IF signal through this. I move over to the IF amplifier tube, and it's considerably weaker, so that tells me we're amplifying, but just not getting any reception, and our audio buzz seems to have gotten stronger. So what the devil happened to this thing? Well, it appears the local oscillator isn't running. I'm getting noise, but no reception, and the voltages just don't add up. Crank the filament voltage up to 1.6, from 1.6 to 1.8, because I've seen these sets, if the tube was a little weak or if the filament voltage would get a tad bit low, everything else would work but the oscillator. So let's see what it does now. Nothing, same deal. And I've already checked the oscillator coil continuity and it's fine. So let's try another tube. Even double checking the local oscillator with a scope, and I'm not getting anything, not even with another tube in place. So what's causing, could this mica capacitor have taken a dump? Well, I don't know what's going on with this radio, but I let it sit overnight, came back down, turned it on, and now we have reception. but the audio level isn't worth a crap. It's wide open, and this is all I'm getting out of it.
$50 billion is the Business Paycheck Protection Program for firms crippled by the coronavirus. Democrats stalling the legislation.
And now, as you can see on the oscilloscope, of course, the local oscillator is working. Well, the radio wouldn't be playing, but I just wanted to show you on the scope there.
The data will show that a lot of other...
Flatten the curve and starting to see a reduced
swapped out the output tube when the volume came back up.
New cases.
Now, what happened with the local oscillator, I have no earthly idea.
There is the deadliest day. You can distribute serologic.
And what's funny is this output tube is a brand new tube that will not work in the radio. It just suddenly decided to die.
We've seen Trump time. Trump time
just for the heck of it, let's test it on the tube tester and see how it checks. And right off the bat, it shows a short on the tube tester, so no need in going any further. Checking with the ohm meter, it seems that every element of this tube is shorted together. Plate, control grid, and filament, screen grid, all shorted together. Reads about 88k ohms. And this is a brand new tube, True Tone branded, with a 188 EIA number on it, which means it was made by General Electric. So yeah, this was a tube that suffered infant mortality. So that explains the audio condition. I don't know why the local oscillator all of a sudden decided to start working. Now, if you're wondering, where's the distant oscillator? Well, I guess that would be the radio station transmitter.
As hemp oil or CBD, but thanks to it.
Yeah, I need to find a pointer for it. And I need to procure some chassis mounting bolts. That's one of my pet peeves, by the way. It seems like 3/4 of the radios I get, the chassis mounting bolts are gone, are missing. Now, if you took them out, you need to put them back.
Text GREAT to 48542. Text GREAT to 48542.
Dennis Prager and my friends, they're at it again. The left is doing its best to silence ideas it doesn't like. Hollywood does not want you to see my film, No Safe Spaces, which...
And for a battery set, this sounds real good.
80's not getting younger and healthier. This Laker roster's older, not a lot of tradable. The cap's coming down. It's a crappy...
Mike Gallagher.
Hi, Mike. You know, you have a great point. I was really sick. And the thing...
And now we interrupt this video to bring you an unboxing, and just because it's the cool thing to do these days, we're going to go over the box with a Clorox disinfectant wipe. I see styrofoam and padding. So yeah, they went to more effort than the average eBay seller, but did they go to enough effort? That remains to be seen. Yeah, I reckon they did. A little Emerson radio that will be the subject of another video. And yet another unboxing. Let's see if we can get lucky twice in the same day. I see lots of foam and padding, so we're off to a good start so far. Yeah, I reckon we're going to get lucky twice in the same day. Can't believe getting 2 radios in one day, and both senders actually went to some effort to make sure they got here in one piece. And this is a Sentinel from the late 40s. Looks like a pretty nice one. Probably one day it'll get repainted, but it's not too bad as it is. And I'm surprised nobody else bid on this. Seems like here lately on eBay, the radios have been getting bid up. In fact, just last night I had my eye on this little Cathedral radio. It was a little 4-tube TRF set with a curtain burner power cord. Now mind you, the cabinet was in bad shape. It looked like somebody had drilled a hole in the front of the cabinet to add some other kind of control. And I was interested in it until the bidding started going crazy, and almost $200 is what it went for. Which just really galls me. Yeah, you know, I'm happy for the seller, but why is a Cathedral radio that's fallen apart and obviously been molested worth almost $200? I was thinking to myself, yeah, it must be nice to have that kind of money that you can just dump a couple of $100 on a radio that's fallen apart and not think twice about it. But anyway, let's open this up and see what the inside looks like. Okay, 4x6 inch speaker, 6-tube chassis. Nice loop antenna that's mounted on a hardboard back, not some cardboard back that's going to shred. And provisions for external antenna and ground. Yeah, this ought to be a decent radio once it's fixed up. Alright, the speaker and the Sentinel tubes I'm finding are date coded 1951, so a little bit newer than I thought. I see one of the IF transformers has been replaced. And the speaker has an EIA code of 270. I can't remember what that's for. Maybe QAM, I don't know. I'll have to go look it up and see. But yeah, I think this will be a pretty nice radio. But we'll work on that on another day.
There's a big...
Okay, it's been on for a few hours, hadn't missed a beat. I did go back and clean the tube sockets, which is something I failed to do. When I wiggled the output tube, it got all distorted and acting stupid, so I cleaned that, and now it's working fine. So now all we got to do is find a pointer, and we'll be in good shape.
Here's the common sense case for doing it at the end of April.
We are Meridian's Gospel Connection, Praise 95.9 FM and Praise 910 AM.
He says the President...
That kind of special.
Well, then you have to decide what special means. I don't think he's that talented.
And there's your AM selection in my area.